Hello guys, Might is back with another video, and today we are effectively on our third problem in the series. So we have 47 more problems to go in the next 47 days because I'll be releasing a new video every day from now till then. And for the new people, if you haven't already subscribed, please click on the subscription button below so you get notified whenever I release a new video. There's a lot of content that's coming, guys, so if you like the video, please like the video, share with your friends so we can grow the family. Let's go. So I've already taken the time to copy the problem from Project Euler. Like I said in the previous video, we only need to go back to Project Euler when we need to check if our solution is actually correct. So this is the page over here. If you want to go there, that's the link, or you can also find the link in the description below. So yeah, let's go back to the code. So I already have the problem definition over here. So the problem definition says the prime factors of 13195 are 5, 7, 13, and 29. What is the largest prime factor of this big number over here? Let me attempt to read it. So it's 600 billion, 851 million, 475,143. Yeah, I think that's it. So yeah, that's the problem we're trying to solve. We're trying to find the largest prime factor of this number over here. So I will close this side on the side so you can give ourselves more space. So we have things that we need to define before we actually start solving our problem. So we have a prime here. They're talking about a prime factor. What is a prime number? So a prime number is a number that is only divisible by 1 in itself. So I'll give you examples of prime numbers here. So we have 2 being a prime number. So I'll just comment that out here. So actually, let me just make a list. I'll make a list const. I'll call it prime, and then I'll just list the prime numbers in there. So the definition for the prime number does not include 1 because it says 1 in itself. So I guess it does pass that that argument, that statement, but it is not included when they talk about prime numbers. So looking at 2, we have 2, right? 2 is only divisible by 2 and 1. And then what's the next one? Let's look at 3. So we have 3. 3 is divisible by 3 and 1. And then if we look at 4, 4 is divisible by 4, 2, and 1. So 4 is not a prime number because it's also divisible by 2. So if we look at 5, 5 is divisible by 5 and 1. And then 6 will not be divisible by, will not be a prime number because it's divisible by 2 and 3. Looking at that, we effectively know that all even numbers cannot be prime except for 2 because all other even numbers are divisible by 2. So 4 is divisible by 2, 6 is divisible by 2, 8 is divisible by 2. So those cannot be prime numbers. So we can look at 7. 7 is a prime because it's divisible by 7 and 1. So yeah. So looking at this, so it looks like we'll need to be able to know if a number is prime or not. So let's start off with that and try and write a function to see if the number is prime or not. So I'll call the function is prime, and then it takes in our number, and then it should tell us whether the number is prime or not. So using that definition I just gave you right now of a prime number, how would we do that? So if we were given a number, let's say we're given a number 5, right? To check all the things that divide 5, we need to look at things lower than 5, because everything greater than 5 will not divide 5, right? So that means we have to look at all the numbers less than 5 and see if they divide 5. So what we can do is we can start off and see. So we already know that 1 is not a prime number. So let's say we are given the number 1 here. If we're given 1, we just want to return false, right? So I'll go over here and say if n is less than or equals to 1, because we don't include negative numbers here, so we want to return false. So we want that to give us false. So if we pass 1 there, or -1, it should just tell us that that is false. So now, after that, we need to loop all the numbers less than n and see if they divide n. And if none of them divide n, then that is a prime number. But if at least one divides n, then that means it's not. So we can go, I'm going to use a for loop, and then I'm going to use our favorite iterator I. And then where do we start? So we already know that our number here that we get is already not 1. It can't be 1 or anything less than 1, because as soon as we hit this code, our code will stop here. It will not continue down because we're returning this statement. So that means our iterator here should be 2. So we're starting at 2, and then we want to see if that I is less than n, and then we want to increase our I. So that's what we get. So now, if I divides if I divides our number, which means that I mod n mod I should give us 0. That means that I divides n. So that's what we want to know. So if I divides n, we know that, okay, something here divides n, because we're not actually looking at n over here. So if something divides n, that means n is not a prime number. So I'll just return false over here. So this will effectively stop our loop. So when we return inside a for loop, the for loop stop. It doesn't continue. So this just returns the result to us outside of the loop. So this will effectively stop. So I'll show you how the code is executed in a bit. But now, if we did not find anything in here that divided n, that means our n is effectively a prime number. So we can actually just go return true. So that means anything that makes it out of the loop is a prime number. So let's test our code. I'll console log. Let me close this guy at the bottom. We'll open it when we need to. Prime. We'll go. It's prime, and what do you want to check? We want to check if 2 is a prime number, right? And then we can check I'll do this. Is prime 2, is prime 3. Actually, instead of me doing this, I'll do it this way, so that I don't have to name everything I do. So we'll see the first one. I'll check is prime 2. And then we want to check a couple of numbers. We have 3, we have 5, and then we can test 4, and then we can also test 7 and see. So I'll just open this guy up here, and then I'll try and run our code. We are running that. So let's look at that number over here. So the first one in the list is true, because 2 is a prime number. The second one is true as well. Third one is true because it's 5. The fourth one is false, which is 4. And then the fifth one is true, which is a 7. And those are the prime numbers that we saw when we looked at prime numbers. So yeah, so we could say this works for us and it's giving us the right solution for our prime number. So now, since we want to find the largest prime factor, let's try and solve the second part of the question, which is what is the largest prime factor of the number, that number over there. I'll just write the function down here and call it the largest prime factor. It also takes in a number n, and then we want to find the largest prime factor for that particular number. So we effectively want to find all the numbers that divide this number, right? Not all, yeah, all the numbers that divide this number, and find out if they are prime or not, right? So what are we going to do? So we need to loop the numbers below n. We want to loop those numbers and then continue from there. So we're gonna need our for loop. So we're gonna say for let I equals to, we'll come back to the value of I in a bit, and then I'll go I less than n, and then I'll go I plus plus. So what should be the value of I over here? So we want to see if the number I is actually a prime, if I is the prime divisor of n. So that means we can try and say 2, because we know that 2 is our lowest prime. We want to see if this number over here, I, is a prime number, right? If I is a prime number, so we'll say if I is a prime number, right? And I divides n. So and if, and, so I'll go and I divides n, which means that n I should give us what? Should give us 0. If that is the case, then we want to say that is our prime number. So now we know that I is going up. So every time we go up and find our prime number, that means that's the largest prime in the sequence, right? So I'm going to store our largest prime in. I'm going to define our largest prime outside of the loop, and then I'll give it 2. Since to start off with, we know that our largest prime should be 2, right? And then that means we can actually effectively start at 3 over there. So we want to update our largest prime every time we find a number that divide a prime number that divides n. So we will do that, and we will go I should be largest prime should now be I. And then what do we want to do? We want to return our largest prime number. We want to return our largest prime number to us, because after we've gone through the loop, we'll say, okay, this is our largest prime number. So we're saying if I is prime and I divides n, then we update our largest prime, because we're moving up. So I is increasing. That means as we go up, that will effectively be our largest prime number. So yeah. So let's test this code out. So we'll go largest prime. Sorry, I'll just run that. So console.log. Let me choose this over there. Console.log. So what do we want to test? We want to test. Let's start with this one and see if it gives us 29 as this is saying over here. So it's saying 29. So let's run it. Oh, it says the largest prime is 29. So we did get the right one for our test case over here. Now let's try and run it for this guy over here. So I'll run it for this, and then let's see what we get. So by the looks of things, this is not going so well. So we don't have an answer yet. This is because this is a very large number. So this is a very large number, and our code is actually taking a while to run, and I actually don't know when. So I'll stop my code. So to stop the code on your machine, just press Control C on your machine. So just press that, and it should stop. So this will not work for us. So we need to find a better solution. I will explain why it doesn't work in part 2 of this video. So I'll see you then. Let's go.